Mars looks close. When you see it in the night sky, it doesn't feel like another world, it feels like a destination waiting quietly in the distance. A place we could reach, a place we could step onto, a place that might one day feel strangely familiar despite being so different. But here's the real question that most people never stop to think about. What if Mars didn't have to stay the way it is right now? What if we could take a completely dead, frozen planet and slowly turn it into something alive? Before we go further, if this kind of content pulls you in, like, comment, and subscribe, because by the end of this video you're going to understand whether humanity could actually transform an entire planet or if it's just a powerful idea we want to believe in. Because terraforming Mars isn't just a scientific concept discussed in labs. It's one of the most ambitious and extreme ideas humanity has ever seriously considered. And once you understand what it would actually take, you begin to realize just how far beyond normal human thinking this idea really goes. At first glance, Mars seems like the perfect candidate for something like this. It has a day that's almost the same length as Earth, lasting just over 24 hours. It has seasons that shift as it orbits the sun, just like we experience here. It has polar ice caps that grow and shrink over time, giving the illusion of a living system. There's even strong evidence that billions of years ago, liquid water once flowed across its surface in rivers and lakes. That means Mars was not always the cold and lifeless world we see today. Something changed, and whatever that change was, it reshaped the entire planet. It stripped away its warmth, its atmosphere, and possibly even its potential for life. What we're looking at now is not the beginning of Mars, it's what remains after everything else was lost. Right now, Mars is completely uninhabitable in almost every way that matters to human survival. The average temperature sits around -60 degrees Celsius, making it colder than the most extreme environments on Earth. The atmosphere is incredibly thin. Less than 1% of Earth's atmospheric pressure, which creates conditions the human body cannot tolerate. The air is made up almost entirely of carbon dioxide, with almost no oxygen to breathe. If you stood on the surface without protection, you wouldn't just suffocate slowly. The low pressure would cause the fluids in your body to begin boiling, a process known as ebullition. Your lungs would not be able to function, and your body would quickly shut down. This is not just an environment that is uncomfortable, it is instantly hostile to human life. And even if you could somehow survive the pressure and lack of oxygen, there is another invisible threat constantly present. Mars has no global magnetic field, which means it has no natural protection from radiation. On Earth, our magnetic field acts as a shield that deflects harmful particles coming from the sun. Without that shield, the surface of Mars is constantly exposed to solar radiation and cosmic rays. Over time, this radiation damages cells, increases cancer risk, and makes long-term survival extremely difficult. It also slowly strips away the atmosphere, which is one of the reasons Mars ended up the way it is today. So if we want to terraform Mars, we are not just adding life to a planet. We are trying to rebuild a system that has already failed once before. So the challenge of terraforming Mars is not just one problem, it is a chain of interconnected problems. We need to increase the temperature of the entire planet so that water can exist in liquid form. We need to thicken the atmosphere so that pressure becomes stable and survivable. We need to introduce oxygen so that humans can breathe without assistance. And we need to protect all of this from being stripped away again by solar radiation. Each one of these problems is enormous on its own. Combined, they represent a level of complexity far beyond anything humanity has ever attempted. This is not building a city or even colonizing a new land. This is attempting to redesign an entire planet. The first step most scientists focus on is warming the planet. Right now, Mars is too cold for stable liquid water to exist on its surface. Without liquid water, life as we understand it cannot take hold or survive. One of the most widely discussed ideas is to trigger a greenhouse effect on a planetary scale. This would involve releasing large amounts of greenhouse gases into the Martian atmosphere. These gases would trap heat from the sun, gradually raising the temperature. As the temperature increases, the frozen carbon dioxide and water in the polar ice caps would begin to sublimate and melt. This would release more gas into the atmosphere, thickening it and trapping even more heat. In theory, this creates a feedback loop that slowly transforms the environment. But there is a major problem with this idea that changes everything. Recent studies suggest that Mars may not actually have enough accessible carbon dioxide to create a sustained greenhouse effect strong enough to warm the planet significantly. That means even if we triggered this process, it might not reach the level required to make Mars habitable. The chain reaction could start, but then stall before it reaches a stable point. This forces scientists to think beyond natural resources already on Mars. It means we might need to bring materials from outside the planet. And that introduces a level of complexity that pushes the idea even further into the extreme. One of the more dramatic ideas involves redirecting comets or asteroids toward Mars. These objects often contain water ice and other volatile compounds that could contribute to building an atmosphere. If guided correctly, their impacts could release energy and gases into the Martian environment. Over time, repeated impacts could help increase atmospheric pressure and temperature, but this is not a simple or safe process. It would require precise control over massive objects, moving through space at incredible speeds. A miscalculation could result in unintended consequences, including damage to any future infrastructure on the planet. It is a solution that works in theory, but presents enormous risks in practice. Even if we somehow solve the temperature and atmosphere problem, we still face the challenge of oxygen. Humans cannot survive in a carbon dioxide-rich atmosphere, no matter how thick it becomes. To create breathable air, we would need to introduce biological processes that generate oxygen. On Earth, this transformation was driven by microorganisms that used photosynthesis to convert carbon dioxide into oxygen. This process took hundreds of millions of years to significantly alter Earth's atmosphere. Trying to replicate this on Mars would require either patience on a massive timescale or advanced bioengineering. We might need to design organisms specifically adapted to Martian conditions. Even then, the process would be slow, gradual, and uncertain. And all of these efforts could still be undone by one fundamental issue. Mars does not have a magnetic field. Without it, the solar wind will continue to strip away the atmosphere over time. This means that even if we successfully build a thicker atmosphere, it may not last. Some scientists have proposed creating an artificial magnetic field to solve this problem. The idea involves placing a powerful electromagnetic shield in space between Mars and the Sun. This shield would deflect solar particles, reducing atmospheric loss. While the physics behind this idea is sound, the engineering challenge is enormous. It would require building structures on a scale far beyond anything humanity has achieved so far. Then there is the factor that most people underestimate completely: time. Terraforming Mars is not a project that fits within a human lifetime. It is not something that would be completed in decades or even centuries. We are talking about a process that could take hundreds or thousands of years to reach completion. It would require continuous effort across generations, possibly across entire civilizations. The people who begin the process would never see the final result. This makes it not just a scientific challenge, but a philosophical one. It forces us to think beyond immediate rewards and consider long-term outcomes on a scale humanity rarely deals with. So why even attempt something like this at all? Why invest so much energy, resources, and time into transforming another planet? The answer goes beyond curiosity or ambition. It touches on survival and the long-term future of humanity. Earth feels stable and permanent, but it is not guaranteed to remain that way forever. Over long enough timescales, environmental changes, cosmic events, or other factors could threaten life on this planet. Expanding beyond Earth increases our chances of survival as a species. It reduces our dependence on a single world. And Mars represents the first realistic step toward that possibility. Terraforming Mars is not just about creating a new place to live. It is about redefining what humanity is capable of achieving. It represents a shift from being a species that adapts to environments to one that can reshape them. Whether it happens in the near future or thousands of years from now, the idea itself changes how we think about our place in the universe. It forces us to ask not just what is possible today, but what could become possible over time. And that question may be more important than the answer itself.